The official recommendation in the United States and other Western countries that the public should not wear face masks was motivated by the need to save respirator masks for healthcare workers. There is no scientific support for the statement that masks worn by non-professionals are not effective. In contrary, in view of the stated goal to flatten the curve, any additional, however partial reduction of transmission would be welcome, even that afforded by the simple surgical masks or homemade DE masks, which would not exacerbate the supply problem. The latest biological findings on SARS-CoV-2 viral entry into human tissue and sneeze-cough droplet ballistics suggest that the major transmission mechanism is not via the fine aerosols but large droplets, and thus warrant the wearing of surgical masks by everyone. The Surgeon General tweeted, "Stop buying masks, they are not effective." The Center for Disease Control's (CDC) states that surgical masks offer far less protection than the N95 respirator masks, which also must be perfectly fitted. These guidelines are not rooted in scientific rationales but were motivated by the need to save the valuable masks for health professionals in view of a shortage. But they may have had unintended consequences. Stigmatizing those that wear masks in the public, "You are a hoarder," or "You are contagious." Contrast this with the cultural habit, the encouragement, or even mandate to wear masks in Asian countries, which have now flattened the curve or even have had a flatter curve from the beginning. Sure, surgical masks and improperly worn N95 respirator masks do not offer perfect protection. But if the stated goal is to flatten the curve as opposed to eradication of the virus, we have to abandon the black and white thinking and embrace shades of gray. We cannot any longer claim that masks are not effective. We cannot allow the perfect to be the enemy of the good. What if however partial protection afforded by leaky surgical or even self-made masks reduces transmission probability to an extent that is similar to that of the recommended, equally imperfect, distancing by more than Fig. 1. Since the CDC provides no scientific evidence for its statement that masks worn by the public are not effective, here we review the scientific support for protection conferred by surgical masks. We focus on mechanistic rationale as opposed to epidemiological phenomenological evidence. We conclude by considering cough droplet ballistics and the latest research findings on the biology of transmission of the SARS-CoV-2 virus, which causes COVID-19, that any physical barrier, as provided even by makeshift masks, may substantially reduce the spread of COVID-19. If we are soon to yield to the pressure to loosen lockdowns and allow limited social interactions to revive the economy, then public masks should have a role and could facilitate a middle-of-the-road approach. The official recommendation by CDC, FDA and others that masks worn by the non-healthcare professionals are ineffective is incorrect at 3 levels. In the logic, in the mechanics of transmission, and in the biology of viral entry. The logic of 100% protection. But imperfect protection does not mean completely useless, much as a glass not full need not be empty. I would gladly accept a glass of water filled to 60% when I am thirsty. Absence of evidence of protection is not evidence of absence. But in our binary world, the official message that surgical masks are not effective may have sent the wrong message. That they are absolutely useless. Sadly, with the black and white picture painted by officials, the discussion about the effectiveness of masks has been stifled, and with it the possibility of incentivizing industry to ramp up production of these 75 cents a piece protective devices. But with the declared goal to flatten the curve and not to totally eliminate the virus, we have a relative as opposed to absolute goal, which places the notion of partial protection in a new light. In principle, one could compute the extent y of flattening of the curve given a partial protection by X% as conferred by mask. But for that we need to first understand the mechanic is a complicated, understudied matter. Droplets can, for this discussion, be crudely divided in 2 large categories based on size, Fig. 2. A. Droplets below a diameter of 10 micrometer, the upper size limit for the definition of aerosol, particles so light as to be able to float in the air. For brevity, let us call this category aerosols. These small aerosols are carried by ventilation or by winds and thus can travel across rooms. What makes N95 facial masks different from the surgical masks is that the former are designed, as per regulatory requirement, to stop aerosols. They have to filter out 95% of droplets smaller than 0.3 b. Droplets larger than 10 micrometer, reaching 100 or more. Let us call these large particles spray droplets here. For a more detailed discussion, see Nikas and Jones, 2009. Of course, droplets can be even larger, up to a size visible to the naked eye, and the spray generated by coughing or sneezing fall to a surface within 2 meters, depending on size, air humidity and temperature. But coughing or sneezing can shoot them like projectiles out of the mouth, with a muzzle velocity of 50 meters per second for sneezing or 10 meters per second for coughing, and droplets can reach distances as far as 6 meters away. If so, then the much-mentioned safe distance of 6 feet in social encounters may not suffice, except you wear a simple mask. More on that later. Here is the central biological implication of the distinction between aerosols and spray droplets. For airborne particles to be inspired and reach deep into the lung, through all the air ducts down to the alveolar cells where gas exchange takes place, it has to be small, Fig. 3. Only droplets below 10 micrometer diameter can reach the alveoli. By contrast, the large spray droplets get stuck in the nose and throat, the nasopharyngeal space, and in the upper air ducts of the lung, trachea and large bronchia. The droplets of a typical cough expulsion have a size 0.00 of the expelled volume, Nikas et al. 2005. It is follows that the sophisticated N95 masks, designed to filter out the smallest particles, help to prevent droplets from carrying the virus down to the alveoli. But is this really relevant for flattening the curve? We shall see below. By contrast, it is plausible that the large droplets that end up in the nasopharynx can be stopped by any physical barrier, such as simple or surgical or dust masks. Of course, many aerosol droplets in the exhalation or cough spray may not contain the virus, but some will do. In the case of the SARS-CoV-2 virus, it is not known what the minimal infectious load is, number of viral particles needed to start the pathogenesis cascade that causes a clinical disease. But we begin to appreciate whether the small aerosol or large projectile droplets are more relevant. The tacit notion at the CDC that the alveoli are the destination site for droplets to deliver the virus load, the alveoli are after all the anatomical site of life-threatening people, as well as many armchair experts who now, owing to message binarization, think that masks are useless. Even with respect to the small aerosols, we must not forget that the partial filtering provided by surgical masks is better than nothing. In an experimental simulation of the filtering capacity of masks in 2008, Van der Sande and her colleagues in the Netherlands compared the ability of 3 masks. I. Homemade, D. Of T-cloth, i.e. standard surgical masks, and E. FFP2, the European equivalent of N95 masks, with respect to their ability to stop small aerosols in the range 0.2 to 1 droplets that reach the lower lung. What the authors found for inward protection warrants some questioning of CDC's message that surgical masks are not effective. While FFP2 or N95 masks indeed filtered out 99% of particles, thus reducing the aerosol load by 100-fold, the surgical masks lowered the number of aerosol droplets behind a mask, still by a substantial, and the F95 respirator masks would be even smaller. Interestingly, for outward protection, the effectiveness and differences are much smaller, see numbers in the Fig. 5. These results raise the urgent question. If all we want is to mitigate the pandemic, that is, to flatten the curve, how much does a 4-fold reduction of particles that reach the lungs decrease transmission from person to person? Intuition suggests that even an imperfect mask may offer some protection that is at least in the range of the recommended separation by more than 6 feet in social interactions or wasting hands or not touching your face. All recommendation based on mechanistic plausibility without strong epidemiological support. Technically, one could quantify by how much the reduction by 4-fold of the droplets that a person is exposed to, as achieved by surgical masks, or by 3-fold, as achieved by makeshift T-cloth masks, contributes to a reduction of the reproduction rate from the initial R0 to the effective RT after mitigation intervention at time T, perhaps by flatten the curve to the desired extent to avoid overwhelming the healthcare system, see Figure 1. But such bottom-up calculation of R is complicated because it would require knowledge of many mechanistic factors that are not easy to quantify. For instance, we do not know to what proportion COVID-19 is transmitted via large spray droplets versus small aerosols. Only in the latter case will the advantage of N95 respirator masks over surgical masks be fully realized. We also do not know how much social distancing alone contributes to reducing R. Thus, let us have a look at the actual biology of transmission, which offers a way out of this problem and has also not been considered by officials who claim that surgical masks are not effective. 3. The biology. The SARS-CoV-2 virus, like any virus, must dock onto human cells using a key lock principle, in which the virus presents the key in the cell, the lock that is complementary to the key to enter the cell and replicate. For the SARS-CoV-2 virus, the viral surface protein spike protein S. The cellular lock protein that the SARS-CoV-2 virus uses is the ACE2 protein Fig6. This cell surface enzyme normally has a cardiopulmonal protective function. ACE2 is expressed at higher levels in the elderly, in people with chronic heart failure, or with pulmonary or systemic arterial hypertension. Note that ACE2 expression is rate-limiting because other host proteins whose presence is also needed for the virus to enter the cells, such as proteases, are more abundantly and widely expressed. Certain blood pressure drugs, as now intensely discussed since hypertension is a risk factor for progression to ARDS and death in COVID-19, but also mechanical stress from ventilation, ironically, can increase the expression of ACE2. Surprisingly, ACE2 expression in the lung is very low. It is limited to a few molecules per cell in the alveolar cells, AT2 cells, deep in the lung. But a just published paper by the Human Cell Atlas (HCA) consortium reports that ACE2 is highly expression of ACE2 protein suggests that the SARS-CoV-2 virus infects these cells. One can also infer that transmission of the SARS-CoV-2 virus will occur largely via large cough or sneeze droplets, which comprise the vast portion of the sprayed liquid in cough-sneeze, and will land in the nasopharynx due to their size, precisely where the molecular locks for the virus are present, allowing viral attachment and entry into the host cells. Obviously, this route of transmission could be effectively blocked by simple physical barrier. The proximal expression of ACE in the nasal cavity also supports the transmission by surface droplets, hence, indeed, wash your hands. In fact, Wolfel et al. Now report that viral material can be readily detected and isolated from nasal swabs, unlike in the case of other airborne viral infections, such as the original SARS. Compared to SARS, which also uses ACE2 to enter cells, in the case of COVID-19, viral genomes, RNA, appear earlier in nasal swabs and at much higher concentration collection, instead of deep in the nasopharynx. The molecular analysis also showed that the SARS-CoV-2 virus is active and replicates already in the nasopharynx, unlike other respiratory viruses that dwell in deeper regions of the lung. The viral replication in the nasopharyngeal mucosa may also explain positive tests in the prodromal stage and transmission by healthy carriers, and perhaps the anosmia seen in early stages of COVID-19. But this biology also means avoiding large droplets, which cannot enter the lung anyway but land in the upper respiratory tracts, could be the most effective means to prevent infection. Therefore, surgical masks, perhaps even your ski mask, bandanas or scarf, may afford more protection than portrayed by governmental official in their initial, understandable but unfortunate, recommendation against wearing of masks by the public in general. N95 respirator masks may offer relatively little additional protection than thought. To be fair, the CDC suggests use of scarf by healthcare providers as properly, will at worst not hurt and may at best help. Make sure to discard or launder after use without touching the outward surface. These simpler, inexpensive masks may suffice to help to flatten the curve, perhaps a bit, perhaps substantially. Importantly, using them will not take away valuable N95 respirator masks from healthcare workers. The implications: it would be tragic if the wrong logics in mechanics and biology, which has led Western governments to not encourage, if not stigmatize the wearing of masks, may have contributed to the steep rise of COVID-19. Given that the upper respiratory tract is the major site for SARS-CoV-2 entry into human tissues, wearing simple face masks which exert a barrier function that blocks those big projectile droplets that land in the nose or throat may substantially reduce the production rate R to an extent that may be comparable to social distancing and washing hands. This would then double the effect of mitigation in flattening the curve. Looking forward, if we are soon loosening the lockdown due to the freedom, that risks resurgence of the invisible enemy. There is now a robust scientific basis for putting an end to the officials' anti-surgical mask hysteria and to recommend or even mandate a broad use of masks as in Asian